We're looking at questions here about tangents, and in particular we're looking at a question about tangents which are perpendicular to a given line. So we remembered that the slope of ax plus by plus c would be minus a over b. Obviously the slope here of a parallel line will also be minus a over b. The only difference in those are the constants which would relate to the y-intercept. Similarly, this slope down here would be minus a over b, but this guy is a perpendicular line. Now the slope of this one is minus the coefficient on x over the coefficient on y, which will be b over a. And we remember that if we multiply minus a over b by b over a, we're going to end up with minus ab over ab. It is minus 1 because the product of the slopes of perpendicular lines is minus 1. Okay, the following example shows the method for finding the equation of two tangents. So, to find the equation of the two lines perpendicular to 2x minus 3y plus 18 equals 0, which are tangents to this circle. Well, again, we'd start off with kind of figure out all the information you can. We got a center of 1 minus 2, and again, how do we get that? We multiply the minus 2 by minus a half to get your 1. We multiply the 4 by minus a half to get your minus 2. So we have our center. We figure out the radius. It's the square root of g squared plus f squared minus c. So we figure out the radius to be the square root of 13. So the radius length is root 13. What we can say then is we can say that we know the tangents which are perpendicular to the line 2x minus 3y plus 18 equals 0 are going to be a distance of root 13 from the center. Now, the tangents which are perpendicular to 2x minus 3y plus 18 equals 0 are of this form: 3x plus 2y plus k. Again, we'll say this is the slope of the line. That's going to be minus 2 over minus 3. It is 2/3. Makes sense, doesn't it? That's an upward sloping line, fairly gradual. The slope of this guy, we call him mt, is equal to minus 3 over 2. And again, 2/3 times minus 3 over 2 will give you your minus 1. So these lines here are perpendicular to the given line. They're downward sloping more steeply than the original line, so it makes sense. Okay. What do we know then? Well, we can say the following. We know the slope of these lines. We know their form, 3x plus 2y plus k. Sometimes students say, well, how can they both be plus k? But we'll see we're going to get two different values for k. These tangents are a perpendicular distance of root 13 from the center, which is 1 minus 2. So what do? We use our perpendicular distance formula. The perpendicular distance is the modulus of ax1 plus by1 plus c all over the square root of a squared plus b squared. The perpendicular distance is the radius length. It is root 13. We fill in everything we know. A times x1. So x1 is the x coordinate of the center. So it's 3 times 1 plus b times y1 plus c. C was your unknown in the equation of the tangent. It is k all over the square root of a squared plus b squared. It simplifies down to the modulus of minus 1 plus k over root 13. So what do we have here? When we simplify it down, we got root 13 equals the modulus of minus 1 plus k over root 13. Multiply both sides by the root 13, and we get 13 is equal to modulus of minus 1 plus k. Again, we're going to take our plus or minus case method. You can square both sides and work out fine, just a little bit longer. The plus minus case for dealing with modulus makes it nice and quick. You get k equals 14 and k equals minus 12. Those are my two answers for k, and therefore my two equations are 3x plus 2y plus 14 equals 0 and 3x plus 2y minus 12 equals 0. So it looks like a tough enough question when you start, but the maths of it are not as bad as some others. So if you practice those ones, you'd have a good chance of getting it right.